Alright, and we're here with a couple of examples from Power Standards Quiz 25 and 26. Got 25 up on the screen asking you which is the graph of the equation 6x plus 7y equals 42. We have four graphs on the screen. We have to identify which of these lines represents all of the points that are represented by the equation 6x plus 7y equals 42. And if we're going to draw a line or graph a line, we need 2 points. At least 2 points to graph the line. And what I'm going to do with these 2 points is much like we did with the last couple power standards, is we're going to find the x and y intercepts. Those are the easiest points to find on a graph because we get to plug in zeros. So the first thing I'm going to do is take this equation, I'm going to plug in 0 for x. I'm going to find the y-intercept of this equation. And the y-intercept is when x is 0. So I'm plugging in 0 for x, so I have 6 times 0 plus 7y equals 42. And when I do this, I get 7y equals 42, and therefore y is equal to 6. So the y-intercept of this equation is 6. Then I'm going to find the x-intercept by plugging in 0 for y. So we have 6x plus 7 times 0 equals 42. 7 times 0 is 0, and we have 6x equals 42. And if 6x equals 42, then x equals 7. So the x-intercept of this equation is 7. And again, the y-intercept is 6. Of these graphs, which of these have a y-intercept of 6 and an x-intercept of 7? If we look at this one down here, this has a x-intercept of 7, matches that, but a y-intercept of -6. So this can't be the answer right here. This one has a x-intercept of 6, doesn't match 7, so that can't be correct either. This one here has an x-intercept of 6. Doesn't match that one. This one looks pretty similar. This has an x-intercept of 7, which matches what we found, and a y-intercept of 6. So this graph right here is the graph of the equation 6x plus 7y equals 42, and we found that by identifying the x and y-intercepts. This is a point on the line. We know that for sure, where y is equal to 6, because we have that right here. And then we have our x equals to 7 right here, and then all these other points that are in between those two would also satisfy this equation. Next example is asking which table satisfies the equation 12x plus y equals 165, and we're given several tables here. And the first thing I'm going to notice here is that we have all our x values are 7 through 11. So we have 7 through 11, 7 through 11, 7 through 11, and 7 through 11. So we're plugging in those values to find out, and then finding out what the value of y is. And you'll notice that all of the values of 7 have a different y value on the output. So all I'm going to do here is just plug in one of those 7s in for x and then find out what y is, and that's going to have to be our answer. I won't have to go through the rest of them since these first 4 points are all different. It's either going to be 7 and 67, or 7 and 47, or 7 and 81, or 7 and 33. Whichever one of these points satisfies this equation, that table then has to represent the equation. So I do 12 times 7, and I plug in 7 for x because that is the x value we're given from the table. So we have 12 times 7 plus y, because I don't know what the value of y is. I'm going to find out what that is, and that equals 165. We get 84. 84 comes from 12 times 7 plus y equals 165. And then from here I can subtract 84 on both sides, and I get y equals 81. So what this means then is that when I plug in 7 for x, I get 81 for y. When 7 is x, 81 is y. When I come up here and I plug in 7 in for this x, this y has to be 81 to make this equation true. The only table that has 7 and 81 is this one here, so this is the table that represents that equation. And if I was to plug in 8 in for x, I could plug in 69 for y, and that sentence would make sense. If I plugged in 9 for x and 57 for y, this equation would be true. If I plugged in 10 for x and 45 for y, this sentence would be true. And if I plugged in 11 for x and 33 for y, this equation would be true also. So this table represents this equation.